In this video, I'll give quick review of HuggingFace transformers. What are HuggingFace transformers? How pre-trained tokenization works, Python implementation of HuggingFace and PyTorch TensorFlow. Let's see what's the background of this HuggingFace. It's an AI community and machine learning platform created in 2016 by Julian and Thomas. It aims democratize NLP by providing data scientists, AI practitioners and engineers immediate access to over 20,000 pre-trained models. Based on state-of-the-art transform architect, these models can be applied to text in over 100 languages for performing tasks such as classification, information extraction, question answering, generation translation and etc. Here you can see speech, vision, tabular data for regression, classification problem, reinforcement are basic application of this algorithm. It provides thousands of pre-trained models to perform tasks on different modalities such as task, vision and audio. These models applied on text, video, images and audio. You can go back with this resource to find out what is the illustration part of this entire scenario. Let's print basic library and importing pipeline from my transformer module. What is the pipeline? It allows you to sequentially apply a list of transformers to pre-process the data and if desired conclude the sequence with a final predictor for predicting modeling. HuggingFace, being a hub for shared models, contains thousands of pre-trained models. You can use these models using the most basic object in transform library called pipeline function. I'm going to run this code and this is going to import another cell which is called sentiment classifier. I'm going to create this sentiment classifier. With this sentiment classifier, I'm going to use this sentiment analysis. Now I'm going to see this device is set to use CPU because I'm working locally and this is offline portal. And I'm going to analyze some text. For example, I'm expected to join teleperformance company as data engineer. So I'm going to test this sentence whether it is positive or negative. Can you see it's giving a score, not only the score but also label whether it is positive or negative. I can use another model as well for the certain purpose. For example, I'm going to use this LLM BERT based NER, name entity recognition. How you can use this one? You can check this library and this is the link which is accepting so many other parameters, so many other tools as well. Here you can see this is showing different model name. First one is fine tuning distill BERT, second is the fine tune BERT large cased, and then is fine tune available both cased and uncased version. This is slightly better performance. And how many parameters are used? This is going to illustrate over here. Now go back to the another parameters. What kind of other base do we have? We have another transformers. For example, these are used with different content, they are supported models, they are supported charts. You can go back here for further classification. Can you see this is the basic model? So I'm going to import this model. You can go back this terms, you can see what kind of name is there. Can you see? I'm going to use this term so that this is the showing this model. So I'm going to use this code and so this is the NER. I'm going to run this code. Can you see this is showing entire entity, what kind of showing this value. This is showing beeper and score, index number, word is there, and so on. Okay, now I am going to copy this example, and this would be another example. So I'm going to deploy this function. Inside this one, I'm going to deploy this term. Can you see this is going to classify every word here: entity, score, index, and their relevant values. But what is this BRG and ORG? You can come back here and you can see this would be illustrated over here. If I go back here, you can see this is showing B, everything is showing here. For example, B MIS, so this is beginning of miscellaneous. MIS stands for miscellaneous, PA stands for person, and ORG stands for organization. So I'm going to illustrate everything here. This is the abbreviation and description is given in this link. LOC stands for location. This is B stands for beginning of location. I stand for the miscellaneous identity or inside this value. Okay, O stand for outside the name entity. So this is entire abbreviation giving in this text, and they are recognizing in the same context. Here you can see this and single statement is just divided into different entity, score, and word as well. Now what kind of other proportional we can go back? We can classify zero shot classifier for the same name. So I'm going to use this classifier which is showing the Facebook BERT term. So once I am going to use this model, from where you will be finding this one, you can use this reference and you will find this term. I have already opened this one, this model. This page is showing BERT large MNLI. So what is MNLI? It's a multi-linear, and this is the multi-NLI, and data set is showing here. And again, it is having so many other parameters. For example, zero shot classifier is where we are not providing any example, mini short or like large fine tuning. So you can copy this model from this link. So I'm going to import this Facebook BERT large MNLI, and this would be providing certain scenario there. Okay, now I'm going to define sequence to classify certain language. So I'm going to define this sentence: one day I'll see the world. So which label it is going to define? One day, for example, I'm going to show one day I'll join teleperformance as machine learning engineer. So this would be sentence. To which sentence or to which class it is going to elaborate? So here I am having three labels. First one is the travel, second one is the cooking, and third one is the dancing. So this sentence is belong to which label higher? If it is belonging to dancing, if it is belonging to cooking, it is belonging to travel, or what? And what would be the relevant score for this given sentence? We are going to analyze that part. This would be analyzing that part and going to classify this one. Can you see? I just defined this word and going to define zero shot classifier algorithm for the given sentence. Can you see? It's just analyzing and predicting that kind of score. So this is my final score, and here you can see travel, it is giving this much square. Yes, this is kind to join, so this is more relevant to travel. Is it relevant to dancing? No, it's not relevant dancing, so score is very less. It is relevant to cooking? No, it is not going to cook this anything, so it's not relevant to cooking and dancing, and more relevant to traveling. This is how you can predict your classifier and you can go back to your sentence. So I'm going to use another sentence. For example, I'm going to create another sentence sequence to classify. My aim is to sing songs for Lord Jesus. So whether it is belonging to devotion, whether it is belonging to sports label or travel label or dancing. So which score would be very high to this relevant sentence? This is my relevant sentence. Let's check this same function for this algorithm. So I'm going to provide this function and hit run, and let's see what's the score now. Can you see this is showing this aim? My aim is to sing song for Lord Jesus. Its devotion is 97%. So this is 97%, most probably belonging to devotion. Travel, very less, no. Dancing, very less, 0.009 means around 0.98%. What about the sports? It's around again 0.86%. When we talk about this travel, it's again 0.98%. And what about this score? This is 97.1%. So this is how you can use these algorithm, these model to classify your sentence. If you want to use the description part, you can go back here and check these entire classification. This was just a small hands-on. I'll see in the next video we will see the other parts. For example, I'll be using pre-trained tokenization, I'll be using auto tokenizer in the next video, so that we can train our own model with more parameters. Thank you.